Okay, alright guys, so we will start the tutorial on attaching these two C channel, and then I will show you how to cut the bottom side of the C channel, and then to make sure that it is connected and become an L, so that both C channels will be welded afterwards, and then the welded C channels with the structure of L will be sent to the static analysis. With the static analysis, we'll do the bending test, whereby the horizontal part of the channel will be withstanding some load, let's say 1 kilogram or 10 newtons, and we'll look at the deformation afterwards. So this C channels has properties like what is shown in this file name. So it has a 0.1 inch thickness, and the length is 200 millimeter, 200 millimeter or 20 centimeter. The thickness is 0.1 inch or 2.54 millimeter. So the thickness is about 2 mm, 2.5 mm. Now you can then try to, if you want to look at the value, yeah, it's about 2.54 mm. So it's about 2.5 millimeter thickness. So this is also 2.5 millimeter. 2.5 millimeter. Okay, so we send this part to assembly and design. It's not been sent, so we open assembly design and then click on product one. Make sure that it is activated. How to know that it is activated? When the color change to orange, and then go to insert and click on existing component. So the component should be from this folder. So I open the C channel, 0.1 inch times 200 millimeter, and and then I want to add the same one into this product one. So just click Ctrl C or copy, and then click on product one, click and paste. So you get the data directly, so you get the file directly pasted in this product tree. So I have part 1, C channel 1 and C channel 2. You actually can rename all this file, turn it enter, or right click on the button and then click on properties, so you can change the part name. For instance, this is part number, maybe we can do part 1.1 for example. Okay, no, so this one should be the C channel, the aluminum C channel, and what's inside here will be the part number. Okay, and then we need to take out all the necessary toolbar that we need to use for assembly. So these are the things. If you cannot find your button, you can just take out all the buttons hidden in this right hand side bar. Okay, so I'll use this now manipulation. Manipulation box, and then I'll choose rotate around any axis. So actually I want to rotate about Y axis, so I find this axis and we'll rotate this thing. Okay, so this is the other C channel. Okay, but our design should be this C is pointing upwards and not downwards, so we need to rotate it, rotate it about I think Z axis, maybe, no, cancel. Should be in the X axis, yeah. So it should rotate about X axis. Okay, and okay, I need to move the sorry, in Y axis. and also x-axis. Yeah, and then I click OK. So if I want to make sure that these two are parallel with each other, so we'll use tackle string. We'll use side string. Okay, 0mm. Can then just delete this again if I don't want to use it. I just don't want to make sure that these two surfaces are really parallel with each other, perpendicular. Okay, or yeah, parallel on the same plane. And then I want to actually attach these two. So to attach these two, I need to cut. For example, this one, if I cut from here to here, so I'll need to make sure that this side also being cut with the same angle and size. So to start with that cutting, I will just choose the model here, double click on this. When you double click on this, you will see that in the assembly windows, you are actually now transferring to a sketch or part design. So what you need to do is, yeah, you have to sketch and then create a model, a part body, a new part body, and that when this part body is then used to do the Boolean operation, and the Boolean operation will be remove. So firstly, we start with opening this thing, opening this tree into the part design, and then click on the C channel here on the yellow gear, click on insert, and then click on body. So now you have the second body, and with the underline, white underline here. That means that now it is in the working object. It's defined as working. Okay, now what we want to do is we create a sketch by having this body to highlighted. So we do sketch on this surface. Okay, so the sketch, what type of sketch I want to have. Of course, we need to first we need to sketch the line. Alright, so of course this snap-on point is activated. I will just need to deactivate it. So then next one, I need to create a line from here to here. So because I cannot attach to any line here because it is actually virtual, so I can create a 3D projected line. So it's inside this toolbar. You have to find this project 3D elements button, click on it, and then yeah, and then I can start searching for the lines that I want to project. Okay, so you see, actually I'm highlighting only this face, but suddenly this interface also become highlighted. This is because these two are interconnected because they are from the same part. Okay, but it doesn't matter, it's okay with that, and I'll continue my sketching, and yeah, I can attach the line there. So next, I need to make sure that these two lines, the adjacent lines, have the correct angle of projection. And then, okay, if this is correct, then I need to disable these two yellow lines because they are not needed anymore. So I need to find, yeah, this one. So go to here, this one, quick trim, and then just delete this and delete this one, another one. Okay, so with that, I think I have finished the diagram, and then with that I need to pack this body. It should be inside the body too. Yep, so the sketch is made too. Final project, scanning. Okay, that it's not a big deal. Yeah, so the size should be 1 inch. Reverse direction. Click OK. It's telling me that it has some problem because it must be use tick option or to use an open. Okay, it does mean that my sketch has some problem over here. So what's the problem I have is, okay, so these two lines are not connected. Okay, so I think it should be okay. The way to yeah, you see, the way to look at it is actually we can do a sketch analysis, but because I know what's the problem there, I can just delete the line that I don't need and then reconnect the line that is not completely connected. Then I just exit the sketch. Okay, so I should have the sketch in orange color. It means that it is a complete sketch. Okay, and then we are just pad, nothing, no warning will appear. No warning will appear. And just click preview and then I click OK. So this is our new part, new body part inside the same channel, the same part. So what I can do now is right click on the body tool, go down to the body tool object, and then we select the Boolean operation, and in this case we can click remove. So you see, remove means that we remove the body from our sketch here. Alright, so it's great that we have done it correctly. Next, what we can do is just double click back on product to come back to our assembly window. And next, I want to attach these two together. So what's the point of view? This surface, I can do that by creating a contact constraint between these two surfaces. Click on another surface and then I click on the update. You can see that this is connected but not as the desired surface. So what I can do, maybe I can just delete these two and then make sure that yeah, the constraint between these two lines are in the correct direction. Okay, but still because these two surfaces are offset, so we can change the offset to 0 and click on OK. So yeah, so we have defined our surface correctly. So I can just delete this if I don't want to yeah, transfer it to my synthetic analysis. Okay, with these two being defined, actually we have finished assemble our material. Again, we have to check whether this channel have material is assigned to it. Yeah, it looks like nothing. So what I can do is can assign the material first. So in this case, I would change the, I would select steel instead of aluminum, because steel is weldable material compared to aluminum. So I want to iron. I would choose iron first and then click on apply material and then click OK. Okay, so both has iron inside as the material property, and then only we can proceed with the next process. But before that, I think I want to disable this axis plane. Okay, For that, then I can go to Start, Analysis and Simulation, and then click on Generative Structural Analysis. Alright, so while waiting, like I said, we will then define in this static analysis. We select static analysis, click OK. So what we can define now in our static analysis, I can just also hide this. We need to define the connection. So like I said, in real life we will then weld these two parts together so that it's combined, and then when we want to use it as our for example channel, the holder for example some load, an aircon for example, I can just create this product again here, and then create a load out there. We don't, in static analysis, we don't really need to define or to draw all of the thing and then send for analysis. We can actually simplify the model by having only, let's say, the holder, and then we define the loads. With that, it's also already enough to see what's the deformation of this holder could be in the post-processing. So in this case, I would say that I would start with defining the pre-processing requirements. So firstly, we can see that under nodes and elements we have tetrahedral mesh 1 to the mesh 2 for both parts, this one and this one. And then under properties, only 3D property for both materials, for material for both. And then under static case, we have restraint, load, static case solution, and sensor. So on the sensor, there's only two default value, energy and global rate, error rate. Actually, we can add more sensors so that we can look at it. But now we have to define the constraint. So I take out the important toolbars here. So for the constraint, we have this restraint toolbar, and then loading toolbar, and then lastly this is the calculator, the computation, and this is the report function. Okay, define material function and the rulers, and yeah, some other useful toolbars. Okay, so firstly, I want to say that I will clamp this surface because this surface normally is clamped to the wall, and then I want to define the force. But before we define the force, I want to define the connection, and the connection is welding. So what we can do is we select the here analysis ports here, and in this case we use line analysis connection, because when you choose this, we have the opportunity to choose the component, the first component and the second component that are connected by lines, and the lines will start with this first line, click OK, and then we have to repeat all this process until we finish selecting all the lines that is available. So in this case, I think we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 lines. So we have to repeat this 12 times. Yeah, then just bear with me on this process. Okay. Only 1, only 2, and then lines. Only 1, only 2 lines. Okay. Okay, so we have selected all the 12 lines there. I want to check on it. We can see here now a new tree is open, and you can have analysis connection and all the 12 connection lines are defined. Next, to make sure that the lines are meshed properly, we need these connection properties. So for these properties, we have to find the similarity connection property, and then this type we need to change to rigid, and then the support is then stated with the lines that we have created the white line there, and we have to again repeat this 12 times. Make sure that rigid property is selected, and then you can see every time that I select the line, the white line, there's this clamp rigid body definition is then assigned to the specified lines. So we have to define the mesh element as rigid, so that the connection is then simulated as a rigid body. Last one is this one. Okay, so we should have under nodes and elements also 12 welding connection, and this represent the 12 lines that we have here. So I want to minimize it so that we can see properly. So we have three things: the analysis connection, the nodes and elements, and lastly the properties. Okay, so well, now we have defined that these two are connected, welded together. Then only I will start with the definition of the force. And the loading, I find this distributed force, and I would like to click on this surface, in this one, surface together, and then in the Z direction I would change to 10 Newton. Because it should be showing downwards, so I choose -10 and then click OK. So this means that the holder here, the C channel as the holder, will have the load located ataupun or standing on this channel shoulder. Then if you want to change that definition to put this surface, then you have to look at the real situation. So because we have a C, so normally we have the load either on this surface or on this surface. So let's say I take the case that the loads are on this C shoulder instead of on this surface, and we want to see what's the effect of 10 Newton load on the C channel steel, made of steel, in this configuration. Okay, I can just compute everything, and then we'll see the post-processing image. So to have that post-processing image data, I have to find this image toolbar, and then click on firstly I want to see the deformation. So you see the deformation is not that bad, because maybe with the acceleration of 500 times also, it's not that much, maybe because this is made by steel. So and for Mr. Stress, you can see that the highest maximum value of this bending load is 3.14 10^6, and if I want to change the color of this material that you see image, you can click on this customize view parameter, this box, this is a cylinder with question mark, and then go to the mesh shading, click on material, and when you click on OK, you can see that the place or the position where the highest stress will exert is at this corner, at this edge. Okay, so you can see now these two are connected really well, and yeah, and it's bended. On the C bends, we can see the stresses are on this edge. If you want to look at the deformation, displacement, uh, I want to change the view to some average ISO, so I double click on the ID vectors on the screen and click on average ISO, and then you can click OK. So in this case I want to yeah, nothing. I want to change the color here. Double click on this color, click on this triple dot color edition, choose smooth. If you want to have more data, more than 10 data, you can click in the number there. So I choose to have 15 color codes or 15 digits, different files. And then if I want to put this deformation and the volume stress deformation side by side, you can just open the static case solution and click on sorry, yeah, I have to activate it first. Now you have both volume stress and translational displacement magnitude, and the highest stress occurred on the material after the 10 Newton force exerting on the shoulder of the C channel is at this corner. So if I want to separate these two, I can choose now the image layout in here, image layout, and then explode and lock in the y-axis, and the distance between these two, it should not be too much, maybe 300 mm or 200 mm is enough. Alright, so click OK on that in the y-axis. Next is, yeah, okay, next is I can also ask for animation from these two, and then change the step size to 50 to make it slow motion, to make it move in a slow motion, and then yeah, so you see the step number of 50. This is the effect of 10 Newton force acting on the C channel on the shoulder, and it bends, start to bend. Okay, so the highest value of deformation is 0.017 millimeter, but the highest moment stress reach 3.14 tempo 6 Newton meter square, Newton over meter square, or it's about 31 so 3.14 megapascal. Okay, so to pause that. So if I want to open the report in the solver, I can just click on the report button here, and then click on Finite solver log. Okay. Okay, so I choose the Edge as my browser, and yeah, when I scroll down, I can see yeah, the data collected in your CATIA. Okay, so